Well, thanks for dropping into my shop here. I'm going to continue working with this radio here. This is a Philips 922 radio. If you've watched my previous videos on this, then you know I've done a fair bit of work leading up to this point. We're trying to chase down a couple things. One is general poor performance, and the other one is this static crashes. It sounds like some part, like a capacitor, failing. My concerns are the part that's failing, it's inside one of these two cans. And if it is, working on these is not easy. And there's some risk involved too. So I'm trying to eliminate all other possible causes of trouble and try to avoid digging in these unnecessarily. But it may come down to, in the end, I'm going to have to figure out which one of these two. Now we have a couple of approaches here. Lots of interesting suggestions from my previous videos on how to nail down just where the noise is coming from. The approach I think I want to take this morning is play the radio, get the noise, and then try to trace it into a circuit area, perhaps one stage, one of the RF stages or something like that. And then having done that, I'll have a much better idea which few components it could be that would cause this kind of trouble. So that's how I want to approach it. Some of the other ideas were get out the cold spray. I don't have any cold spray, although I have alternatives. And cold spray the various components, and hopefully you'll hit the one that is weak, and the cold spray would reveal it. I haven't had a lot of luck with trying that, in the past. I have to take off. There's a short on this on-off switch that I put on, so let's start by taking that off. Because a couple of times there I've forgotten about it and kind of expected the switch to do something, and of course it won't. And I'm going to relocate you. Looking for a nice spot for the camera to go here. Bring out my spare camera stand. Hey, it looks like a red toolbox. Yes, well, it could be a red toolbox, or it could be a camera stand. Depends how you look at it. There we are. And you can start to see a lot of the parts I've replaced already. Resistors, capacitors. About 15 parts have been changed in this. So, oh, one of my cats is showing up. Guess what? Come on up here. This is Peanut. Peanut's never appeared on camera before. There he is. Look in the camera, Peanut. Look in the camera. Peanut. There you are. Okay. No, I think he wants to go outside. That's why he's down here meowing at me. So that's two of my cats that have made it on camera here. One is Peanut here, and the other is Draper, who has made a number of cameo appearances in previous videos. Okay, so I have to give him a little bit of a head scratch while we ponder the next situation here. Yeah. There we go. So, as I was saying, I think it's a question of isolating the stage where the trouble's coming from. I already know from the volume control that it comes ahead of the volume control, because you can turn the volume down and the noise goes away. Yes, hey, look at this. Look what I got for you. Look. Look. Whoa. Look. See this? There. No, don't rub it. It just wants a head rub. Yeah. I think Peanut was a little depressed yesterday. He wasn't his usual happy self. He usually runs around with his tail straight up. Yesterday he was not so happy. Okay, now we got to get back to doing some radio work here. Chase this ball. Okay, I'll take care of him for a while. Now, let's set up the radio to operate. That's what I need to do, for crying out loud. So, I'm going to hook up a speaker. I'm not going to get too far without a speaker. And then just twisting the speaker lead wires together here. I'm not doing anything fancy. Peanut, you're back already. What happened? You lose your ball already? Okay, quick safety check, but there's nothing. Everything's nice and neat. Oh, I didn't remove the thing. Let's unplug it. That's what happened. I was going to remove that, and then the cat showed up, and I got all sidetracked. And I did not solder this, so it should be pretty easy to get it out of here. Yeah, I connected it pretty good. Now the short is on here. Again, if you didn't watch the earlier videos, there was a time where I thought the radio noise was coming from a defective switch, on-off switch. So I shorted it out, and guess what? Didn't make any difference to the noise. So it was not the switch, but I left the short in place right up until now. So the switch should operate now. Let's plug it back in. Put the power on current limiting. And we'll switch it on. Here we go. We're on. I don't know if you can see it. Yeah, you can. The supply voltage dipped way down during the inrush. Supply voltage is going up as the radio's current draw falls, as the heaters heat, and once the heater and the cathodes heat up, there we go, we get a little more current draw from the current flowing through the tubes coming on. So and there it is. Holy smokes! Where did that come from? See what I mean? Did that come out of the volume control? Yeah, I might say yes to that. Wow. I threw some cleaner in there. It doesn't seem to have had any effect. Let's try that again. A little more cleaner. Wouldn't normally do this with the radio operating, but I don't think there's much risk here. I'm not sure I got any in there. Definitely some went in that time. There was a point where I was pretty sure the tone control was completely interrupting the circuit. I'm not even sure if it could do that. Tone control. No, it should not be able to interrupt the signal completely. It seems to be cleaning up. Volume's full. It's really pretty noisy, isn't it? Okay, radio, I think we can say that the noise is not coming from these controls at this point. It's coming from somewhere else. Now another very likely thing is the band switch, as has been suggested to me, and I'm concerned about because when I looked at it closely, it was not in very good shape. Now, every time I've done the, turning it slightly and all that to try to initiate noise, it's never ever happened. So every test I've done suggests the noise is not coming from the switch. But let's try some more. Volume's up full. Now I'm just going to stress the switch, move it just a little wee bit. See, there isn't a sound. Let you go all the way to the next band. Either there's a contact absolutely making no contact ever, or see that sounds just fine to me. Well, let's give it something to chew on here. We've got to give it a signal. We'll just feed it from the antenna right now. I won't use the signal generator. So this is my antenna connection. Look at that. This radio's alive and well. Maybe it's recuperated. Let me put the volume down. Make the connection. Look at that, eh? What band am I on? I can't remember. The volume is strong too. Remember before we were having weak and strong. This is strong still. Okay, now I'm on the highest shortwave band. Volume up very high now. Good chance of receiving stuff up on this band. Where's the crackling? I'd say this radio is working just fine. Picking up tons of stuff. There's a funny effect here. I don't know if you're noticing it. So I think that's a religious station. So hopefully I can't get a copyright hit. I come across songs like this when I'm doing this, and I get copyright claims for just a couple of minutes or a few seconds of this stuff, so, and it's a hassle. I don't want to get them, but that sounds great. Now, no doubt that's a strong signal, but lots of weird stuff in there, like lots of birdies.
Federal law, and they use the word law. I don't know, there's one lawgiver, we realize that. But they had a federal regulation in, what was it, 1905? Yeah, they used to authorize this, and here we are, 100 and some years
well,
later.
I don't hear any noise.
Now they're changing their mind. I mean, to me, it's just a glaring example of the fact that they never play by their own, they don't follow their own rules. They don't play by, they say one thing and then do another. So,
they say one thing and they do another. Who are those people? Well, until it starts making noise again, there's not much I can do. Oh. We're still running on reduced voltage. Not really, the voltage at the plug, which is where I measure it, right at the plug that the radio is plugged into, is 114 volts. And that's a normal line voltage. Now I can run my little outlet there, because of the isolation transformer runs much higher. If I let it, it'll go 125. Why don't we put the boots to this radio and see what happens? So here we go. 125 volts.
I appreciate the prayers for you guys, for my dad. He did really good. That next Sunday, he started feeling a whole lot better, and he's been able to. So it's crazy. And I was also wondering if anybody had heard anything about that.
No static at all. So maybe the static I heard in the last video was really these volume control, tone control. Nothing there now. Sounds great, actually. No, I'm not getting any of that static. I can't generate the static.
This morning I've seen that there's already hundreds of people starting to show symptoms of being sick. I didn't know exactly what kind of symptoms it was.
124 volts, 123, 124
Where was that
volts.
exactly? Where was that?
Okay, let's try this other band. That's the high band. Let's try the middle band. Now, a little hard to pick stuff up this time of day. It's definitely tuning. Might get something right at the high end of this band. No. A lot quieter at the one end of the band than the other, isn't it? Now it's quieting down again. Hey, where'd it go? What happened? What was that? It's going up and down here. Other band too. What happened? Ah, this radio's a monster. Okay, let's take it down voltage. Take it down. Turn it off for a moment, let it cool a bit. Turn it back on. What was that? Oh, there's something definitely going on in this radio. You know what's going on? It's going on and off. It's off right now. Something real weird going on. Watch that meter. When the meter's high like that, that means there's no load being drawn. I'm just waiting for it to jump again. I had this radio doing this before. There it goes. Okay, so there's something intermittent here. Stick it where you kind of keep an eye on that meter. I gotta do this quickly, man. I can't fiddle around here. This opportunity may not last. Okay, first, is it a tube? Okay, so I'm wiggling each tube. A slight movement of the voltmeter you're looking at. Oh, this one here. Clearly something's heating up and going open. A slight movement of the voltmeter you're seeing is just the house voltage changing with, you know. Now I'm knocking the tubes a little bit. Seems to be the output tube here. Okay, so another approach now would be to look at the filament voltages across each of the filaments. One of them has the whole 100 and whatever it is, 125 volts across it, because it's open circuited. So let's see if we can't get a hold of that quickly. There. Keep an eye on that voltmeter for me. Oh, because when it drops I can't do this test. So, okay, now. Okay, so I'm reading a voltage, it's jumping like crazy. 40, 40, 40. 48, 49. Okay, so it's holding at 49 where it's supposed to be, but then it's dropping to 0. So this is not the problem, guy. Okay, the next most likely one is the rectifier. So come on, radio, stay off. Rectifier heaters, I think. No, the rectifier gets its own 5-volt supply, doesn't it? Rectifier, quickly. No, rectifier's in the line. Of course it is. 35 W4. Of course it's in the line. Okay. Looking for 35. 123, 19, 123, 120. Holding as still as I can now. Okay, come on, radio. Did it jump there? There it goes. I think it's this guy. Yeah, I think it's the 35W4. Because I saw a high voltage across it. So we got another 35W4 right here. Let's put it in. Lucky break that the intermittent. Sorry about that. The intermittent was just the kind of thing I needed to find that tube. Take him out. Oops! There, maybe if you stay on the ground you won't fall over. How about that? I'll take you off the high perch. Okay, there's a new well, not a new. There's another 35W4 in there. That did not look good. The meter. Do you see it jumping? So either the tube I just put in, it's not. Okay, quickly now. Quickly like a quick bunny. Get the voltmeter out and try to find out who's got all the voltage across the heater. Okay, looking again. Oh, it's exactly the same. Okay, so I'm looking across the heater, and what am I seeing? 123. And I'm just waiting for the short or the open circuit to close. 124. And this is saying this heater, this heater's open too. That's a little far-fetched, isn't it? 2 tubes in a row. The open heater. Well, it's just staying at 124. Okay, let's do a couple more things. I'm going to shut off the power. I'm going to hook up my voltmeter with clip leads so I don't have to rely on my hands holding it in there. For intermittent work, you know, it's better to do this because, yeah, come on down. You hold test leads, and you tend to introduce momentary intermittent connections, so it gets a little tough to sort it out. Okay, so we're connected up there. Sorry for the rough handling of the camera. It's kind of weird. The only way you could see full voltage across the 35W4 is if it really is open circuit. Let's apply voltage again. Okay, we're going to let you see this. Kind of play the game like me. Try to watch this meter and this one at the same time. And this meter indicates the heaters are open. As soon as this meter drops, there, see that? Gotta keep an eye on this one. There it goes. You see that? That dropped. But this is a different tube. I got another one. $35W4. I have another one here, so this one just seems to be open all the time. A small jump there. You know, bad contact in the pull the tube right out. Wait a minute. Now pull the tube out, you should still be able to read the huh? Shouldn't I still be able to read the filament voltage there? Well, if another tube is open circuited on the heater, then yeah, I see a 0 there, but it doesn't explain why I put the tube in and I get something. A reading. So I'm doing something wrong here. Let's check the pins on the 35W4. Quick look here. 35W4, here it is here. Heaters 3 and 4. Pins 3 and 4. I'm certainly not on 3 and 4 here. So I don't know what I was measuring. Certainly seemed to relate though, didn't it? Okay, so pin 1, 2. There's a short circuit in there. Put these resistors in, I introduced a short circuit right there. It's a short circuit to an unused pin, so it might not have made any difference, but let me get rid of it. So that's pin 1, 2, that's 3. That's 3. How's that work? Oh yeah, it comes around. It connects to this resistor, yeah. Okay, so that's pin 3 and 4. So that's really where we should be. What was I doing? I was doing pin 1. Pin 1. Pin 1 isn't used. Yeah, I don't know. I was going by wire color. That was a stupid move. So let's put this on properly. Pins 3 and 4. It's pin 4, pin 3. Voltmeter is connected. Hey, what's happened to my meter? Looks like the pointer's off. I don't know. And my pointer's kind of pointing between the spots now. I don't know how that happened. It's always been dead on, so Anyway. Okay, so I think we're set now to see the filament voltage of the rectifier tube, which is not in place. So with no rectifier tube, we should see 124 on this guy here. And there he is, 124. You can't quite see that. There it is, 124. So we're going to turn it off. I've now mixed up all these tubes. I don't know which one's which anymore. We'll grab one because I'm not so suspicious of them either. Get something else going on. We'll stick one in. And now what we should see is 35 volts when we hit the power here. What do you make of that? So clearly this is not the tube that's in trouble. Okay, power off. Now we'll switch to the 50C5 pins 3 and 4 again. And that's typically the heater pins on many tubes, 3 and 4. 50C5 is right here. 1, 2, 3, and 4. I can verify because of the wire types. That's clearly the heater wire lead. So we're on the 50C5. We should expect to see 0 or 50. There we go. Let me see. 0 and 50. So this is not the bad tube. So from here on it's anybody's guess. So let's try the 12AT6, pins 3 and 4. And the 12AT6 I'm pretty sure is this one here. So 1, 3 and 4. 3 and 4 are hidden. 1, 2, no they aren't. 3. And 4. Okay, so we're across the heater. And again, we should see either 12 volts or 0. If you see anything else, no. So this is not the problem tube either. So now we'll go up to, I don't know what it is, 12BA6 I think. Pins 3 and 4. Pins 3. The wire seems loose there. There's really something wrong with that wire. Okay, that might be a bad connection right there. That's one that I redid. And maybe it didn't take right. Yeah, that doesn't look right. Okay, switch on the soldering iron. I have found something right there. Okay, so this is ready now to check the heater on the 6BA6. Ready to supply power. Here we go. Oh, you see the 76? See the 90? There it is. That's the open circuit tube. Or is it that bad solder joint that's causing that? Once again, maybe I introduced the trouble. Well, we certainly have to. Let's take a good close look at that. Not a bad close look, we're going to take a good close look. So, bear with me while I switch off the autofocus here. You out this way. Go in and take a real close look at that connection. What's going on there? Look at seems to be completely missed. Uh-oh. Wow, I don't know what to make of that. That seemed to be touching that heater lead. That would put a solid wire between pins 1, 2, 3, between pin 4 and pin 6. That would put a solid wire between pin 4 and pin 6. A solid wire between pin 4 and pin 6. I think that's the 12BA6. I saw the wire between pin 4 and pin 6. Of course, there isn't such a thing. So I might have had a little short I introduced there by when I replaced this part. Shouldn't change the reading I got though. So we'll pull out the 12BA6. Make sure it is a 12BA6. 12BA6, and now what we'll do is we'll do a resistance measurement right on the heater pins. Pins 3 and 4. There's pin 3, here's pin 4. Well, it shows it as being good, doesn't it? Well, all we can do is stick another one in there and see what happens. So I'm not going to assume that this guy's bad yet. 12BA, that one's bent over. Okay, let me find a 12BA6 tube here. Okay, I've got quite a few of these. So 12BA6. I'll stick it in there. I wonder if that's been the noise problem, whoops, all along. The bad heater not going all the way open. I'm sure it could cause all the sounds we heard. Hey, which one was the bad one? Yeah. Oh, Peanut has come back. This one was the bad one. Put them over here. Keep my good and bad separate. What? What do you want? You want to go outside? Is that, or do you want to go in the room next door here? Either one will do, he says. What do you think? What do you think? Okay, I'll let you in the room next door. I'll be back. Okay, so if you heard me talk about the cats that are in this house, we have 3 cats, and my wife and I have, and my son who's returned from college brought a cat with him. We have 4 cats here. They're all getting along except 2. The youngest and the oldest don't get along. So we have to keep the old cat separated from the young cat. We keep the old cat in a room just on the other side of the wall here from my shop. And my little cat, Peanut, always wants to go in and visit the lonely cat in the room. Isn't that nice? So that's what he was meowing about. He wanted to go in, and he's in there with the older cat now because they get along. It's the other cat you've met, Draper, who he's a little aggressive. And I won't get into cat society, but just for those of you who have cats, if you haven't realized it yet, cats are very polite animals, and they look for others to be polite, including other cats. They expect polite behavior. And in the cat world, being polite is a little different than the human world, but not that much different. So pay attention to your cats and treat them with, be very polite to them. And they'll respond to that. Anyways, back to the radio here. So I put the tube in. Yes, I did. I think we should turn it on. Yes, I did. And we'll see what we get out of this thing this time. Everything's heating up. Voltage looks steady. I'm looking at the line voltage on the meter here. There's no more jumping around. And here comes the radio. in business.
And that's the shipping. Call 877-817-9829, 877-817-9829, and order your Miracle 2 products today. Then you'll know why so
Your
many people
Miracle
say
2
it's not
products.
just soap,
Certified by God himself. Well, just for fun, we'll take a listen to the AM band, but I think we'll just hear a bunch of hash on it. Let's hear it. Oh, I hear a radio. Very faintly. This radio's working good. And there you have it. I think it's fixed up. Bobby, feast your eyes on those capacitors. Look upon them. Are they the reason it's working? Yeah, you know what? I think replacing all those capacitors generally lifted the radio's operation. The intermittent and all that noise may have been coming from a failing capacitor. There were 2 bad capacitors in here. One of them fried while I was working on the radio. So that could have been the noise, but it seems like the noise continued. Could have well been the heater on the 6 and the 12BA6 going open and closed, and sometimes just harshly opening and causing that noise like we just heard now. I don't think that was the radio, I think that was something else. So we'll go on a quieter band and just leave it running here. I'll leave it running for a couple of hours and see if it acts up. I don't think it will, though. I think we got it. I think it's a thumbs up. But then again, I have raised my thumb optimistically too many times. So, but let's enjoy the optimism. Thumbs up. And like I say, I'm just going to leave this operating. And this, next video, hopefully, is just this thing back in its cabinet. So thanks a lot for watching.